All right, so chapter 2 has a lot of review from chapter P and chapter 1 in it. So the nice thing is you're going to take a lot of things that you already know, we're going to talk about it again, and then expand on those concepts also. So the first thing we're going to look at here would be to identify a polynomial function. So a polynomial function is defined as something that is defined and continuous on all real numbers. Defined and continuous on all real numbers. And what that means is when you look at the function, its domain is unrestricted. So there's no variables in a denominator. There are no variables underneath a square root sign. And so you're going to have to look at these 4 choices and decide, is it a polynomial function? If so, what is its degree, which we have struggled with apparently, and what is the leading coefficient? So look at number 1. Is this restricted? Are there any variables in the denominator? No. Any variables underneath the radical? No. So this is a polynomial function. So let's find its degree. I noticed that some of us are struggling, so let's really understand how to do this. What is the degree of this term? Just the one term? 3. To find the degree of a term, you only look at the exponent of the variables and add them together. Well, typically when you're going to be working on these, there's just one variable term. So what is the degree of negative 5x? 1. What's the degree of a constant? 0. And for those of you who don't realize it, here's why a constant has a degree of 0. If I have, let's just say the constant 5. Every single constant actually has a variable attached to it, and the variable that's attached to it, in this case we'll use x, is always raised to the 0 power. Why don't we see x to the 0? What's the value of x to the 0? 1, because anything to the first power, anything to the 0 power is always 1. So that's why you don't actually see it, but they actually have it there, it's just invisible. And so that's why every constant has that degree of 0. Then to find the degree of the polynomial, whichever term carries the highest degree, in this case 3, that is the degree of the entire polynomial. So because 4x cubed has the highest degree of 3, the whole polynomial has that degree of 3. So we don't go and add the 3 and the 1 and the 0 together. So what is the leading coefficient then? We'll call that LC. It's the coefficient of the highest degree term. 4. Look at number 2. Is number 2, does it have an unrestricted domain? Are there any variables in the denominator?
Yes.
Yes, there are. Why do you say so? Very good. First class of the day to get that. That exponent of negative 4 really means that this entire term can be written as 6 over x to the 4th. So they're hiding the fact that you actually have a variable in the denominator. So therefore, x cannot be 0. Therefore, it is not a polynomial function. It might be a function, but it's not a polynomial function. Yes. Because there were no variables in the denominator, and there's no variables underneath the radical. Those are things that affect and restrict our domain. Right? So it's almost like you're trying to find the domain. And so on this one, our domain would what could be anything we wanted it to, it just couldn't be 0, and because there's that restriction, it's not a polynomial function. So I don't have to find its degree, I don't have to find its leading coefficient. What about number 3? Is it a polynomial function? No, why? It's got this square root here. I'm not going to make you find the restriction because we'd have to set 9x to the 4th plus 16x squared, what? To what? Greater than or equal to 0. We're not going to go through and try to find that right now. But that would be the restriction. So as a result, it is not a polynomial function. Or function. I don't know why I made that plural. Function. Well, what about number 4? Yes or no? Yes. So what's the degree of 15x? 1. What's the degree of negative 2x to the 4th? 4. What's the degree of the polynomial? So the overall degree is 4 because this had the highest degree. Relatives. Oh, no. Let me see. Hang on. It's the overall. But if you, on that one, I'm going to allow that if y'all put in the relative max and min, that I'm going to go ahead and take it. Because I can understand the confusion. Okay. What was that? Yes. I'm getting that. I was distracted. So then what is our leading coefficient? It is negative 2. It is not 15 because this is the degree of the highest term. Make sure that you keep that sign with it. It's going to become important later on. Okay, so then in this particular section, we're going to focus purely on polynomial functions of no degree and low degree. So the first one that we come across is the 0 function. It's in the form of f of x is equal to 0. That's really y equals 0. What is y equals 0 in the coordinate grid? It's not the y-axis, it's the x-axis. So really what we're talking about here is the x-axis. It is a function, but is the only polynomial function that has no degree. Because you can't say that the degree of 0 is 0. It has no degree. So none. It is considered undefined. 0 is always such an interesting number. You could probably have an entire course on the number 0. I'm sure you'll all want to jump up and take it, right? Constant function. Constant function would look like f of x is equal to some number. That is a pound symbol. It is not a hashtag. I know you all think it's a hashtag. It's a pound symbol. And it represents numbers. So it could be f of x equals 5, or f of x equals negative 10. It's really y equals 5, y equals negative 10. So what is the degree of that? Any constant. Degree of any constant. Not 1. 0, right? Because it's x to the 0. Because really what I have tacked on here is x to the 0. All right, then your linear function, your book writes it differently than I'm going to write it, but that's because I, of course, disagree. So I've got f of x is equal to mx plus b. And the only reason why I'm writing it differently than them is because that's what you're used to. I think they write it ax plus b, which is fine. But you should realize that m is the slope and b is the y-intercept. What would be the degree of this? It's only got one variable term. 1. Not x, but that exponent, 1, right? And isn't this the graph of a line? Then the last one we're going to work with in this section is the quadratic function, which would be f of x is equal to ax squared plus bx plus c. What's the degree of that? 2. And this is the graph of what? A parabola. So example 2 is a pure review, but the way they've written it is different. So let's look at how example 2 is written. Write the equation for the linear function f, hint, hint, wink, wink, that has told you the form of the equation, such that f of negative 1 is equal to 2, and f of 3 is equal to, let's change this to a negative 2. If we leave it as a positive 2, we're going to come out with a vertical line, and I don't want that. Linear function, why is that such a good hint? What form is that? Yeah, so f of x is equal to mx plus b. What have they really given me here with this function notation? What does f of negative 1 equals 2 mean? What have they given me? X and we have two things here and a y. Well, which one of these two is your x and which one's your y? Think of it in terms of f of x equals something. So which is your x? Is it the negative 1 or is it the 2? Because remember, this is f of x, right? So if that's f of x, they're telling you that x is negative 1. So this is your x value. If f of x is equal to 2, f of x is your output. This is your output right here. That must be your y value. So they've given you two ordered pairs. So step 1, you are to write the ordered pairs. So our first ordered pair is negative 1, because that's our x value. Positive 2, that's our y value. What is the other ordered pair? 3 is our x value. Negative 2 is our y value. Now, given two ordered pairs, how do we find the equation of that line? I don't use slope-intercept form. But before we do anything, we do have to find slope, right? And then we'll use something else that's typically easier than slope-intercept. So step 2, find the slope. So just a little review on your slope. M represents your slope. That is the change in y over the change in x. The official formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. When you use that formula, remember I emphasize that you use it as a template. So write the formula without the things that you're going to plug into it. Make sure those subtraction signs go in there first, because otherwise you're going to mess up your signs. Then label your ordered pairs. And you label this as x sub 1, y sub 1, x sub 2, y sub 2. And we're going to plug them in. So y sub 2 is negative 2, y sub 1 is 2, x sub 2, since I started with this one, x sub 2 has to come right below it, which is 3, and x sub 1 is negative 1. Your ordered pairs should be vertical to each other with the y up top. They should never be diagonal. Make sure you take care of your signs, add the opposite, so plus minus here and a plus plus there. So I end up with negative 4 over positive 4, which is your negative 1. So slope is negative 1. So if I don't use slope-intercept, what form do I use? Point slope. So use y minus y sub 1 equals m times x minus x sub 1. Much easier. The majority of you who tried to use y equals mx plus b got the answer wrong. These are the only three things that you are subbing in for. The plain x and plain y stay the same. Is that fuzzy to you or is it clear? It's not fuzzy at all? I swear it's got to be fuzzy. All right, so I'm going to write this as a template. And we're going to plug in the values that we know. Now, we have two ordered pairs and a slope. You need to make a choice on this ordered pair of which one you want to use. I typically will look for an ordered pair that has a 0 in it or no negatives. None of which do I get the choice of having here. So I'm going to choose the one with smaller numbers. I'm choosing that one. You can choose the other one and you and I should come up with exactly the same equation. So I choose to plug in for y sub 1, 2. For my slope, m is negative 1. And for x sub 1 is this one, negative 1. It's just a coinky dink that they're both a negative 1. Take care of any double negatives, so I've got a plus plus here. And solve. You have to distribute what's out in front of parentheses before you can add the 2. So I'm running out of room. So I'm going to solve here. So I get y minus 2 is equal to negative 1 times x is negative x. Negative 1 times 1 is negative 1. Add your 2. Y is equal to negative x plus 1. I guess that looks the same, doesn't it? Maybe slightly better. All right, questions on that? Total review, true? Just ask slightly differently. All right, so flip this. Then I put into your homework some questions that talks about correlation, which is linear association. So you might want to put up here that this is your correlation. I took out the word problems associated with correlation. You're welcome. So as you look at a scatter graph, scatter plot, you're looking for a pattern of dots. Doesn't this pattern of dots go in this direction? Is that a positive or a negative direction? So that, and notice that this is also going in a positive direction, isn't it? One of them is a much stronger correlation than the other. This one quite clearly is approaching a very definite path. This is approaching what I would call a fuzzy path, but they're both still in a positive direction. So we call this a strong positive correlation. The more that those points tend to form a line, the stronger the correlation. The weaker the points are, the more cloudy that they are, the weaker that correlation is. So this is called a weak positive correlation. Now if you have what looks like a cloud of mosquitoes, there's no positive or negative direction to it. We've had a cloud of mosquitoes in Arizona lately, have we not? This is little or no association. Or you might be used to calling it no correlation. All the same. So what's the fourth one? Strong negative. Yeah. Look at that. The part you're missing. And this is a weak negative, isn't it? So those should be easy questions. I think there's like 2 of those. Then we're going to use our translation skills, and we're going to translate the parabola. So 6 different translations. I want you to learn something by the time we're done with it. And we're going to take what we know and do something new. So look at the first one. That's all right, I'll do it for you. So look at the first one. What's happening here? What translation? What's that 1/3 on the outside doing? What is it doing? Shrinking it how? Vertically or horizontal? Vertically, isn't it on the outside? Right? So this is a vertical shrink of 1/3. What I would like you to do, and remember when you do your homework, you're creating a study guide. So you should be writing down the original question. You should be writing down any pictures that go with it. In this case, I would be graphing the original parabola so you can see the change and analyze that change. And then your answer. You should not be using this scratch word. If you struggle with a particular question, you should be highlighting that question so that 2 weeks from today you're going to have a test over 2-3. When you study for that test, you'll go back and look at what you highlighted to show that, oh yeah, I was struggling with this, I wasn't sure about it, and that's your study guide that tells you what you need to review. So get in the habit of writing your basic graph. How do I know where these points are? How do I know to plot those? You can plug into y equals x squared, -2, -1, 0, 1, and 2. Plus, the more that you do this, you can just get used to that pattern. And it'll become second nature. If you don't plot this, it's not going to become second nature. So that's the graph we're changing. And I know it's x squared because the function's x squared. When you have any kind of vertical or horizontal strings or stretches, I would suggest that you plot with an xy table. So we're going to create an xy table. And we're going to start with our vertex. So our x value of our vertex is 0. We're going to see how that gets affected. Plug in 0 here. 0 squared is 0. Times 1/3 is still 0. Yay, they had a good time out there. So that point did not change. If that's bothering you and too loud, you can close that door. Because I know it gets loud back there. Then the x value to the right is 1, so we're going to plug in 1. Look what happens. 1 squared is 1 times 1/3. We get a lovely 1 1/3. Ew, that's no fun to graph, but we're going to go ahead and graph it. Over 1, up just a smidgy, 1/3. When we vertically shrink something, don't we shrink it this way? So what do we expect these arms of the parabola to do when I push on it this way? They're going to stretch out towards the x-axis. So it makes sense that this is lower than the original point. And then if I plug in -1, won't I also get that 1/3 point because I'm squaring the -1? So to the left one, up a smidgy, 1/3. Well, if I put in 2, which is this point here, and I square 2, I get 4. Times 1/3 is 4/3. What mixed number is that? 1 1/3. So to the right 2 and up 1 1/3. So this one really got pushed down. And then -2 would also give me 4/3. So -2 up 1 1/3. I can actually fit one more point on here. If I go out one more unit, out to 3, 3 squared is 9. 9 divided by 3 is 3. So I've got 1, 2, 3, and that's a nice one to plot. 1, 2, 3. And -3 is going to be the same thing. 1, 2, 3, 1, 2, 3. So I can get a nice shape to this graph. The more points I plot, the better the shape of the graph. And as you can see that those arms are getting closer to the x-axis. B, what's going on? Vertical stretch of 4. So we're going to run through, do exactly the same thing as the xy table. Here's our original parabola. And we're just going to plug in values. This one we're not going to be able to fit as many points on here though. Now with a vertical stretch, I'm pulling this parabola this way. So what's going to happen to the arms when I pull it this way? These are going to get closer to the y-axis. That's what you're looking for. That's why you're plotting that original graph on here so that you can decide whether you're plugging things in correctly. So if I plug in 0 for x, 0 squared is 0, times 4 is still 0, so that vertex did not change. Plug into the right 1, so plug in 1. 1 squared is 1, times 4 is 4. I can plot 1, 4, so it's the right one, up 4. And -1 is also going to give me 4, so when I square the negative, it's still positive. But what happens if I put 2 in here? What's 2 squared? 4 times 4? 16. I can't fit 16 on there, so I'm not even trying -2. It's not going to fit on there. But I can still sketch a graph, and didn't it go in closer to the y-axis? Yeah. The last of the easy ones is C. What's happening on C? Yeah, so that is a shift, vertical shift, right? Up to, or correct, up to. So this one's easy, no XY table needed. Here's my original parabola. Don't I just move every point up 2? Just like I taught you before. So up 2, up 2, up 2, up 2, up 2. We like ones without vertical stretches and shrinks. Much easier to deal with. All right, then the 3 down below have multiple translations. Let's look to see what happens there. So D. What's this negative here doing? So reflection over the x-axis. That's the last thing I'm going to do, by the way, is reflect it over the x-axis. What does the positive 2 do? The inside is always opposite, so you're correct. Left 2. So here's my original parabola. And I'm going to perform 2 different translations. So I'm going to move it left first before I reflect. And so I'm going to have some interim points in here. So I'm going to take my black, and you might just take a different color if you have it, and I'm going to move the parabola left 2. So every point gets moved left 2. So left 2, left 2, 2, 2, and 2. So my part in black is that movement. Then I'm going to perform my reflection. Since I'm reflecting over this x-axis, I reflect the points the same distance that they are from the x-axis. I jump over it and plot it the same distance on the other side. So if this leftmost black point here is 4 units away from the x-axis, I'm going to go 4 the opposite direction and plot a point. So these are equal distances away from that x-axis. This point is 1 unit away, so I do 1 unit on the other side. If a point is directly on the axis that we're reflecting on, it doesn't move, we don't have another point. When you touch a mirror, you can see your finger touching your reflection. There's no distance between it. This point is a unit away, so we have a unit away over here, and this point is 4. And now connect your points. That should fit better. So then on E, we have what going on? What does this mean? Left 3, and then what does this mean? Down 1. So that's actually nice because there's no reflection, no shrink or stretches. So here's my original parabola. I'm just going to take every single point and move that point left 3 and down 1, then plot the point. No need for an XY table, nothing like that. So left 1, 2, 3, but down 1, plot a point. Left 3 and down 1. So it should still have symmetry. Shape should not have changed. The only thing that changes shapes are vertical and horizontal stretches. Now this last one is a bit of a doozy because it has a reflection, a stretch, a right movement, and an up movement, doesn't it? It has everything in there. So, so the negative here does what? So reflection over the x-axis. And the 3 means what? Vertical stretch of 3. And the negative 1, right 1, and the 2, is your up to. So we could put in the original parabola, which we're going to. And here's your original parabola. And we could move our parabola right 1 and up 2. And then we could reflect it, because the very last thing I ever do would be a stretch. And I still need to kind of plug it in the XY table. So that's what we're going to go ahead and end up doing, just plugging in numbers. But what you want to do is make sure that you determine where do you think your vertex is going to go. Well, if I move my vertex to the right 1 and up 2, because inside is correct, right 1 and up 2, so I go right 1 and up 2, I anticipate that my vertex is going to be there. The stretch is not going to change the placement of that vertex. So I want to start plotting my points where the vertex is, because I like to do symmetrical points. I like to start in my middle and move my way out. So that x value of my new vertex should have an x value of positive 1. I determine that based upon my up, down, right, left movements. So I'm going to plug in positive 1. Positive 1 minus 1 is 0. Squared is 0. Times negative 3 is 0. Plus 2 is 2. Isn't that where my vertex ended up being? 1, 2? So that's not a shock. Then to the left of my vertex is an x value of 0. So I'm going to start plotting in 0. 0 minus 1 is negative 1. Squared is 1. Times negative 3 is negative 3. Plus 2 is negative 1. So I have 0, negative 1. There's that stretch and the reflection. So you can see from the vertex, I'm a lot further away than just 1 unit away like we were before here originally. So I'm further away by 3 actually, aren't I? And I've reflected down, which is what we're looking for. So then go to the right of your vertex, which would be an x value of 2. They should come out with the same answer because they're sister points. They're equal distance away from the vertex. This point was 0, that point's 2. They're equal distance away from that vertex. This is your line of symmetry, if you will. Put that in there so you can see. So that's equal distance. That one should come out to be over here. Let's see what happens. 2 minus 1 is 1. Squared is 1. Times negative 3 is negative 3. Plus 2 is negative 1. And the reason why I do that is it checks. You might have made a mistake on your math. 2 to the left of my vertex would make me at negative 1. Negative 1 and a negative 1 is negative 2. Squared is 4. Times negative 3 is negative 12. Plus 2 is negative 10. Is that going to fit on my graph? No, so I'm going to stop there. So I'm going to connect those points. And there's my graph. Now before we move to the other side, I want to point something out. What was my vertex here? What's my vertex here? What order pair is my vertex? Negative 2, 0. Look at what's inside the parentheses with the x value. What number is that? Negative 2, negative 2. What's outside? Nothing. 0. What's your vertex here? Negative 3, negative 1. What's on the inside here? Opposite sign, negative 3, right? What's on the outside? Negative 1. Don't they correlate? Let's see if that works over here. It's a vertex. On the inside is positive 1. On the outside, same sign, is positive 2. Anytime we work on the inside of the parentheses, it always seems to be opposite sign. Anytime outside is the same sign. And notice that that is my vertex. So I welcome you to what I call vertex form of a parabola. Your textbook calls it standard form of a parabola. So flip your paper. And here it is. So all three of those last graphs were in this form. A times x minus h squared plus k. This is your standard form of your quadratic. You can read your vertex directly off of that form. That's why you'll probably hear me call it vertex form, where the x value of the vertex is h. Notice that's the opposite sign than what you see in here, and the k value is positive k, same sign as what's out here. Remember when you had the equations for a circle? The center of the circle was hk. We always took the opposite sign that was inside the x minus h squared, y minus k squared, took the opposite sign of those and got the center of that circle. It's the same theory here. But you've got one inside and one outside, so opposite sign, same sign. The other thing that you can tell from this equation is right here. Look at A. A could be a number. If A isn't there, then that means it's 1. But if A is greater than 0, you go all the way back to Algebra 1, 2, you learned that in this form, the regular quadratic form is f of x is equal to ax squared plus bx plus c. These are the same a's. Same a's. When a was greater than 0, what did you know about the parabola? Do you remember? Something about it opening up or down. It's positive. Aren't positive numbers up? So this opens up if a is positive. If a is negative, meaning less than 0, it opens down. The other thing that you can tell from this is you can find your axis of symmetry. Your axis of symmetry always goes vertically through the vertex. And so because a vertical line goes through which axis? The x or the y axis? The x-axis. It's x equals, in this case, the x value of the vertex is h. If they ask you for the axis of symmetry, that's what they're looking for. Or you can base it upon your quadratic form of the quadratic, and that would be the opposite of b over 2a, if you recall that from Algebra 1, 2. It comes from the quadratic formula also. So let's use it. You have to be able to take a quadratic that is in quadratic form and put it into standard form, vertex form. We're going to use completing the square, which is why it was so important for you to know how to do it. First thing you're going to do is cut that quadratic into where the two x terms are. You only want the x terms. The constant, if there is one, gets pushed off to the side. So we are going to create this squared binomial, which is why we're completing the square. Whenever you complete the square, can you have a number in front of the squared term? Yes or no? No. So we have to factor it out. So we're going to have f of x equals, I'm going to take this 2, whatever number it is, it doesn't matter if it divides into this middle term or not. Whatever that number is, you're going to factor it out in front of parentheses. You're going to take 2x squared divided by 2 gives you an x squared. 8x divided by that 2 gives you a positive 4x. Then you must put in a plus blank because we're going to complete the square in parentheses. But don't forget about your plus 7. So you got plus 7, but we also have another plus blank. The difference between completing the square this way and completing the square the way we did it before, your plus blanks were on opposite sides of the equal sign. And if we put something on one side of the equal sign, didn't we have to put an equal value on the other side to maintain equality? So we tended to put the same exact number. But this time I'm putting the same thing on the same side. If I want to maintain equality, if I put a positive 10 on this side, how do I make it have no value? What would I have to put here? A negative 10. They will be opposite numbers. However, there's one little catch. Watch what happens with this one. So we're going to go ahead. Question, stretching?
Yeah, I have a question.
I don't want to factor it. And I know that's where you're thinking, factoring. I want to complete the square because I'm trying to get the squared binomial. So don't take out a factor of x. We're only taking out the coefficients because then I can't complete the square properly. Okay? So we're not factoring, just taking out that coefficient because I have to have a 1x squared there to complete the square. And so if you recall, to complete the square, you take c, or to find c, you take b and divide it by 2 and square it. ax squared plus bx plus c, this is your b. Well, now this is our b in this case because we took out a 2. So to find our c, we're going to take b and divide it by 2 and square it. So I get 4 divided by 2 and I'm going to square it. 4 divided by 2 is 2, squared is 4. So on this blank I am adding a 4. However, if you recall from completing the square, this really isn't a value of 4 right here. I really didn't put a 4 here. What did I actually put here? If I were to redistribute that 2, what did I actually put here? You have to view this not as a 4, but you have to always multiply it to whatever is outside here. 2 times 4 is actually a positive 8. So I have increased this side by a positive 8. I have to get rid of that because I've just changed the value by positive 8. What's the opposite of positive 8? So I put a negative 8 there. Multiply what's outside to that number you came up with. Positive 8, the opposite thing goes over here because it's on the same side. Now we're ready to actually write it out correctly. So we've got f of x is equal to, keep what's out in front, 2. We have now completed the square, so this gets written as a squared binomial. Take the square root of the bookends, x and 2. And the sign of the middle term here, in this case positive, becomes the middle sign there. Then don't forget about these two. What's 7 plus a negative 8? Negative 1, so then we have minus 1. Done. So that's the equation. So now we're going to gather data to plot. One thing that I didn't mention, so I'll mention it here. Look at your original quadratic form. If x were 0, that means it's somewhere on the y-axis. I will be able to find my y-intercept. So if x is 0, your constant 100% of the time is your y-intercept. Yes? Because I took the square root of my bookends, so square root of x squared is x, square root of 4 is 2. And then, because the middle sign is positive, that middle sign gets brought down to the middle of the binomial. So back up here, whatever the constant is in the quadratic form, that's your y-intercept. And so this right here, y-intercept, and it's always 0c, because the y-intercept's on the y-axis, so the x value's got to be 0. So as I look at this, I'm going to start gathering the data to plot. My vertex is what? Look at this right here. What's my vertex? Yep, this is your H, and this is your K. Opposite sign inside, so that makes it a negative 2. Same sign outside, negative 1. So I know my vertex is at negative 2, negative 1. My axis, if they ask for it, so if I have negative 2, negative 1, I'd have a point right here. My axis of symmetry goes straight through, vertically through that point. It goes through the x-axis, so it's x equals, at what point? Negative 2. That's the x value of the vertex. So my axis is x equals negative 2. The other important points would be the y-intercept and whether it opens up or down. Does this open up or down? Look at what's in front here. Is that greater than 0 or negative? Yeah. Or greater than 0? Positive or negative. So it opens up. So I expect to be opening up this way. My y-intercept from my original problem here, which my constant was 7, it's 0, 7. So I'm going to plot 1, 2, 3, 4, 5, 6, 7, a point right here. This point is 2 units away from that axis of symmetry, so it should have a sister point 2 units to the left, so here at negative 4. Now I can plot and graph that problem. If they ask for the x-intercepts, then you would be solving this, setting y equal to 0 and solving. Shall we do it again to see if you understood? Why not? So let's look at 6. Are there any questions on that before we do a second one? the -4 because I knew that if this is my axis of symmetry, every point over here is equal distance to a sister point over here. And so if this y-intercept is 2 units away from the axis of symmetry, its sister point is 2 units away over here. Well, that's at -2, so 2 units away must be at -4. Any other questions before I move on? Okay, so let's look at 6. Okay, would you mind shutting that door? Now they're getting a little ridiculous. Thank you. We're having way too much fun in Spanish. All right, so this time we're going to do the same thing. We're going to cut the quadratic right there. I only want the x terms. So I've got f of x is equal to, do I have anything in front of my x squared term? I have a negative. So I'm going to pull a negative out in front of my parentheses, and I'm going to divide each of these by that negative. So it really just changes signs. That becomes a positive x squared. Negative 6x divided by a negative is a negative. A positive 6x divided by a negative is a negative 6x. Don't forget about your plus blank and parentheses. Don't forget about the -8 and the other plus blank. So far I haven't done anything different. Complete your square. So find C. So we're going to take B. You can make it -6 if you want to. I always ignore the sign because it doesn't matter. You're going to square it. So 6 divided by 2 squared. 6 divided by 2 is 3. Squared is 9. I'm going to put a 9 here. Be careful. What value did I actually put on the blank? I really didn't put a 9. Yeah, look at that negative that's out in front and multiply it to the 9. It really gives you a value of -9. So what value do we put over here to create 0? A positive 9. So sometimes we put a positive value out here, sometimes it's a negative value. You have to multiply it to whatever might be out in front of the parentheses. Sometimes there's nothing out in front of the parentheses. Both of these cases there's been something out there. Then you're ready to complete the square. So f of x equals, keep that negative out in front. Because we completed the square, this becomes the squared binomial. Take the square root of your bookends. Square root of x squared is x. Square root of 9 is 3. How do I know what my middle sign is? Middle term. Yep, middle term, middle sign. So because my middle term was negative, my sign inside is negative. Don't forget to add those. What's a -8 and a positive 9? Positive 1. So here is your standard equation or vertex form of that parabola. From there we can start to gather information. What is my vertex? Opposite sign, 3, same sign, 1 is your H and your K. What is my axis? X equals 3. Does this open up or down? Look at what's out in front of the parentheses. Opens up or down? So it opens down. It's negative. And the last thing we want is the y-intercept. Look at your original quadratic form. Isn't it -8? Y-intercept is always a 0 value for x, and then whatever that constant was, -8. 0. Your axis is always the x value vertex, because when I plot that vertex, in this case, 3, positive 1, your axis of symmetry is always a vertical line for these particular parabolas. This is x equals 3, because it goes through that vertex at its x value. And then I'm going to plot my y-intercept of -8. So I have a point here. Now, this -8, isn't it 3 units away from the axis of symmetry? So I have a sister point that's 3 units to the right, so at 4, 5, at 6, so 3 units to the right here. Now I can draw a lovely shape for that parabola. And you want to check that, did it open down? Yes, it opened down. Questions? Okay, very last problem. So the last type of problem that they're going to give you is find the equation of a problem in standard form. That implies that we're going to write it in f of x equals a times x minus h squared. Don't forget that, I do it all the time, plus k. Given that its vertex is at 1, 2, isn't that our h and our k? So haven't they given me h and k? And passes through the point 3, negative 6. Here's 3, negative 6. What they've given you is a plane x and a plane y. This is a plane y. So we are going to plug into this, and we're going to replace the f of x, which is our plane y. We're going to place the plane x, the plane h, and the plane k. They've given us 4 things out of the 5 on that formula. We just have to find a. So here we go. I've got, for y, I have negative 6 equals a times my x is 3 minus, keep the minus in there, my h is 1 squared plus my k is 2. Now do the math. Negative 6 equals a times 3 minus 1 is what? Bless you. 2 squared. Well, let's just write it 2 squared right now. 2 squared plus 2. Then we have negative 6 equals 2 squared is 4, so doesn't it become 4a plus 2? Now can't I'm solving for a, subtract 2. Well, I get negative 8 equals 4a. Divide by 4, and we get a is equal to negative 2. Now I have everything I need to rewrite it, so we're going to rewrite it. We're going to write it in this form, but we're going to keep the plane x and plane y as plane x and plane y. So I've got f of x is equal to, instead of a, we're putting in negative 2, parentheses x. My vertex is negative 1, or positive 1. So don't I put in a negative 1? Minus 1, parentheses squared, and then my k is a positive 2, so I do the same sign for the outside, positive 2. Done. This is the formula for those points. So you're going to feel free to work on your homework this weekend. Do bear in mind, you done? Do bear in mind that we are going to go to the math lab on Monday. So if you chose not to do your homework, that's your choice, but then you may not be able to ask me questions. You might not get all your questions answered. So keep that in mind, it's your choice, but we are going to the math lab on Monday.